Hello all, this is Raghu Narasimha presenting the project for course 1 Machine Learning Foundations for Product Managers, part of AI Product Management Specialization. In this project, CRISP-DM, which is known as Cross Industry Standard Process for Data Mining Framework, comprising 6 phases, is followed, and each phase will be explained in detail. Starting with phase 1. It is important to understand what the business needs are. In this project, the business need is to predict the electrical energy output of a combined cycle power plant, which uses a combination of gas turbines, steam turbines, and heat recovery steam generators to generate power. In phase 2, we will understand the given data. The objective is to analyze if the given data is sufficient, is it clean, and how to handle missing data. The data source comprises 9,568 hourly average ambient environmental readings classified as ambient temperature, ambient pressure, relative humidity, exhaust vacuum, and net electrical energy output. Running some descriptive statistics tool within MS Excel, we notice the data to be clean and the results like mean, median, standard deviation, and variance are captured for reference. Moving on, in phase 3, we will organize the data in preparation for modeling. The data readings, ambient temperature, ambient pressure, relative humidity, and exhaust vacuum will be used as input variables or features, and net electrical energy output as our target variable. All the variables are continuous variables. The input variables AT, AV, AP, and RH have a positive correlation with output or target variable net electrical energy output. This leads us to apply multivariate linear regression model for predicting electrical energy output. Out of 9,568 total observations, we will split 80% comprising 7,654 observations as training data and remaining 20% comprising 1914 observations as test data. In phase 4, we will build multivariate linear regression model using training data and calculate coefficients of the input variables. These coefficients are necessary to validate the model using the test data. We will follow two different approaches. In the first approach, we will consider all 4 input variables or features and build the model. In the second approach, we will drop the input variable relative humidity with least absolute correlation, and we will use remaining 3 input features to build the model. For consistency, the model will be trained with the same training data set and will be used to calculate the coefficients. Next, in phase 5, we will calculate we will evaluate the metrics. The objective of linear regression is to find a line that minimizes the prediction error of all the data points. The essential step in any machine learning model is to evaluate the accuracy of the model. The mean squared error, mean absolute error, root mean squared error, and R squared or coefficient of determination metrics are used to evaluate the performance of the model in regression analysis. Root mean square error, mean absolute error, mean absolute percentage error metrics, which indicate error should be as low as possible. R squared error value, which corresponds to the model fit to the data should be as high as possible. As you can see, we have um, executed those coefficients against the variables in which we obtained in both the approaches and applied this against the test data to derive the necessary metrics. And these metrics are captured and displayed in the screen for both the approaches as shown. We can then move on to the conclusion. The conclusion is, upon reviewing the output metrics for both the models, it clearly indicates model 1 as error values, uh, root mean square error, mean absolute error, and mean absolute percentage error lower than model 2. The R square value for model 1 is much higher than model 2, which proves that the model 1 data fits very well for linear regression model. Remember, the model 1 approach comprises using all the four input variables: absolute temperature, absolute velocity, absolute pressure, and relative humidity to evaluate the above metrics. So it is recommended that we choose approach 1 with all the four input features to predict the electrical energy output of a combined cycle power plant. Thanks for listening in.